Welcome back. Today we are tackling a massive topic for the IGCSE Computer Science 0478 syllabus, loop flowcharts and exam strategy. We've got a lot of ground to cover, so let's just jump right in.
So, picture this. You're sitting there in your paper 2 exam. You've just drawn this absolutely beautiful, perfectly shaped flowchart. The arrows are totally straight, your symbols are spot on, but you placed your iteration counter test at the very end of the loop instead of the beginning. Did testing that counter too late just cost you the grade boundary? Well, the harsh reality here is, yeah, it absolutely can. It's this incredibly painful classic exam mistake. Testing the loop counter at the wrong time literally ruins the logic of your whole algorithm, and it just bleeds precious marks.
And honestly, it gets even deeper than that. The examiner's lens for this syllabus is incredibly strict. Check out this rule. Generic answers are weaker. Scenario questions must use the scenario nouns and constraints. So what does this actually mean for us? It means your ordinary, standard textbook revision completely fails if you don't apply your algorithm logic directly to the nouns actually provided in the exam scenario. Think about it. If the question gives you an array named student, and you just write the word array or data in your answer, no way. You are leaving marks on the table. You really have to speak the examiner's exact language.
Okay, let's dive into this. Here is your very first quick win. We need to clearly distinguish between the two major types of conditional loops you're going to be asked to flowchart. On one side, we have the precondition loop. This is where the condition is tested right at the start before the loop's main instructions even run. On the flip side, we have the post-condition loop. Here, the test happens at the very end. That guarantees the instructions inside the loop run at least once. Knowing exactly when to use which, that is absolutely crucial. It's the secret to bulletproof algorithms. Now, before we start building our flowcharts, let's lock down our terminology. Algorithmic iteration is the repeated execution of a set of statements controlled by a condition. That right there is your perfectly safe, Cambridge-approved definition. But in student-friendly language, it literally just means a loop. It's a way to tell the computer, hey, keep doing this specific chunk of code over and over again, but stop once a certain rule is met. And that rule, that's your condition.
And this brilliantly illustrates exactly what you're going to face in the exam. Let's apply our loop concepts to a very specific Cambridge scenario. Imagine you're asked to output 20 names that have been stored in an array called student, indexed from 0 to 19. Just look at the structure here. You've got the index column running 0 to 19, then the student name column, and finally, the counter variable that basically tracks where you are in the list. Now, pay attention to this. Counting from 0 to 19 still gives you exactly 20 students. This zero indexing trap, it catches students out every single year, for sure. So let's see how this builds into an actual preconditioned flowchart sequence. Step 1, you initialize your counter variable to 0. Step 2, and this is the absolutely crucial part, we test the condition immediately. We ask, is the counter less than 20? If yes, we move to step 3 and output the student at that specific index. Finally, step 4, we increment the counter by 1 and loop right back to the test. Now, because the test happens before the output, if our starting condition was somehow instantly false, the loop would safely bypass the output entirely. That is the magic safety net of a preconditioned loop. Now contrast that with the post-condition flowchart logic. Step 1, again, initialize the counter. But look closely at step 2. We dive straight into the action, output student. Step 3, increment counter. And only at step 4 do we finally ask our question, test if counter equals 20. See the difference? We do the action first, and we ask questions later. The test has completely moved to the end. This setup guarantees that the loop runs at least one single time, regardless of what's going on with the data. So why does all of this actually matter? Well, in a moment, I'm going to reveal the hidden examiner clue that changes your answer entirely based on which of these two loops you choose. Believe me, if you miss this clue, you can just wave goodbye to those top band marks. But first, you really need the framework to make that clue obvious. Let's test your logic with a quick checkpoint. I want you to just pause and think about this for a second. What happens if the student array is totally empty, like it has absolutely zero data in it, but you use a post-condition loop to read it? Remember, a post-condition loop outputs the student first and then checks the counter at the end. Well, if the array is empty and your algorithm blindly tries to output student 0 before checking anything, boom, your program crashes. It throws an error because it's attempting to read data that literally doesn't exist.
And that brings us to how students try to write this out in the theory questions. Consider this pretty flawed answer. I would use a loop to check all the students. Ouch. This is a classic red pen mistake that earns an absolute 0 in paper 2. It's way too generic. It doesn't specify the type of loop, it doesn't mention the array name, it doesn't even acknowledge the condition. It just completely ignores all the constraints of the scenario. Now, what's really interesting about this is how we fix it. If you want those high marks, you need the ultimate answer upgrade template. It goes like this. First, state the definition or concept. Second, explain the mechanism of how it works. Third, bind it tightly to the scenario example provided in the question. And fourth, state the consequence or advantage using precise examiner wording. Let's actually see this template in action. Boom! Here is your upgraded top band answer. A precondition loop tests the counter variable at the start to ensure the student's 0 to 19 array is only accessed if names exist. Just look at the massive difference there. We name the specific loop type, we name the specific counter variable, we included the exact array name and its constraints, student 0 to 19, and we clearly explain the algorithmic consequence. It ensures the array is only accessed if names actually exist, completely avoiding a crash. Guys, that is exactly what the examiner's red pen is searching for. So here's the thing. Designing the loop is honestly only half the battle. Testing your loop logic is the whole other half. In your exams, you're going to need to validate your logic and data structures using 4 specific types of test data. Think of it like a massive stress test for your code. Normal data, that's your everyday expected input. Abnormal data, that is the chaotic user trying to type their name into a phone number box. It's totally erroneous data that should be rejected immediately. Then you have boundary data, which tests the very edges of acceptable limits. Like, if your limit is 20, you test 19, 20, and 21. And finally, extreme data, which tests values right at the absolute extreme limits of the system's normal operational bounds. Now, while we're evaluating inputs, you absolutely have to distinguish between 2 massive concepts that constantly cost students marks: validation versus verification. Validation is an automated check by the computer to ensure data is reasonable and meets certain criteria, like checking if an age entered is between 0 and 120. Verification, on the other hand, checks that data was accurately copied or entered. You know, like when a website asks you to type a password twice to ensure they match. They are completely different things, so please do not mix these up. All right, let's synthesize all of this into our core Cambridge exam strategies. Earning those high marks really boils down to this. First, 1 mark equals 1 distinct point. Do not just repeat the same idea in different words. The examiner is not going to give you double credit. Second, use exact technical terms. Don't write something like it goes round and round. You need to say it iterates. And third, always respond to the specific command word used in the question prompt. And to make sure you never miss out on these essential Cambridge frameworks, listen closely. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Now, we've just spent this entire explainer perfecting your loop logic and making sure your flowcharts are technically perfect. But I want to leave you with a kind of terrifying thought. What if your loop flowchart is absolutely flawless, your variables are perfectly named, your conditions are 100% accurate, yet the command word evaluate in the question prompt still drops you into a lower mark band? I mean, why does this happen? Well, the hidden cause isn't your computer science knowledge, it's how you interpret the examiner's secret instructions. We're going to tear down exactly how command words decide your fate in the very next explainer. You definitely do not want to miss it. See you there.